I'm not going to lie, you guys. 3 5's a lot. 3 5 is a lot, but it's so fun. And once you get it, you're going to be like, this is awesome and so satisfying. There's just a lot going on. So bear with me. Don't quit when you feel like, I don't know where we're at. Just tell me to stop and re-explain where we're at, and we'll figure it out, okay? This is solving systems with 3 variables. So instead of just having X and Y and doing substitution and elimination, you're going to have X, Y, and Z and do substitution and elimination, okay? So if you know substitution and elimination well, you're going to be fine. If you did not do well on the substitution and elimination on the quiz, I need everyone's utmost attention, but I need you to reach out and find a time to sit down with me or something, because if you didn't do well on that on the quiz, you're not going to do well on that right now unless you focus and jump in, okay? Because it's not that we're doing anything different. It's just that we're doing so much more of it in one problem, okay? So here we go. It's kind of substitution and elimination within substitution and elimination is what ends up happening. So first of all, understanding what the solutions are. Basically what's happening here is you're working with kind of like 3 dimensions now, right? So if you look at these pictures, this shows you when you'll get what types of answers. So let's say I have this setup, okay? A blue plane, an orange plane, a like cream colored plane. Is that what they look like up there? There is no place that all 3 of those are touching the same lines, points, any of it, right? Where they're all 3 coming in contact. Same thing with this. There's no place where all 3 are coming in contact. Same thing with this. They're all parallel now. No contact for all 3 of them. Yes, there's overlap for some, but never all 3 at the same time, okay? So those are all no solution situations. When there's one solution is when you have one point where all 3 of those planes meet up. So in this case, it's this little point right here, right? That would be one solution. The place where there's infinitely many solutions is if they're all going in the same direction and you have this line of intersection, because planes keep going, right? Remember that from geometry last year? Planes just keep going. So do lines. So if you have this line of overlap, you have an infinite number of solutions because it's just going to keep going. Okay, so those are the 3 different scenarios. You can have one solution, you can have no solution, or you can have infinitely many solutions. Most of the time, I would say you're going to have one solution where you have x equals 2, y equals 3, and z equals -4. Okay, that would be one solution. So I'm going to show you what that looks like, and I am going to do my very best to color coordinate so you can tell which equations I'm working with, when I'm working with them, and what we're doing, okay? So this first one, it says solve using elimination. So we're trying to eliminate, but you can't eliminate all of them at the same time. So we have to eliminate one variable from 2 different systems, and then we can eliminate another variable from those 2 new systems, okay? Here's what I mean. If I look here at my black equation and my red equation, those are able to be eliminated right now. Do you see it? You have, and I highly recommend copy and paste right now. If you're in Notability, use your little copy tool. Does everyone know how to do that? If you don't, ask your neighbor. It's going to save us a lot of time not having to rewrite every equation right now. So I'm going to take this equation. Anyone need help figuring out how to copy that equation in Notability? Are you all good? Tell me now. You're going to fall behind if you don't. Johnny, do you know how to copy and paste from Notability?
Yeah.
Yeah? Okay. So we're going to take that equation and the red equation and just stack them. Just like this. Okay? So notice this is our first equation and our third equation. Okay? I'm just labeling which ones they are. We're going to eliminate our z. So we're going to add these together and eliminate. That means x, remember this is 1x. 1x plus 2x is 3x. Negative 2y plus a negative 2y is what? Negative 4y. Be careful you don't call that 0. And then z plus a negative z is 0 equals 10. Okay, so now we have this new equation. We got rid of z. But in order to solve for x and y, we have to get rid of z another way also, so that we can have two equations here. Okay, so the next thing we're going to do is we're going to see, okay, where else could we eliminate z? Do you see it? Using which two equations from the very beginning?
Purple and red.
Purple and red. So now take a copy of that purple and red. Okay, I'm going to put that over here. Oops. So this is my second equation and my third equation, and we're going to eliminate my z's. Okay, so add these together. I get 5x. Negative 5y plus a negative 2y is a negative 7y. My z's equals 0. 14 plus 3 is 17. So now we have this equation. Okay. That's the new part. Now you're looking at a system that has two variables, and you guys know how to do that, right? Now we're taking the ones we just got. So take a copy of 3x minus 4y equals 10, and take a copy of 5x minus 7y equals 17 and stack them. Now we're going to do elimination with that. How do we eliminate here?
You can multiply by a fraction.
You could multiply by a fraction. We're not going to. We're going to keep it a little more simple than that. We want to multiply so that we get coefficients that are opposites. Okay, so what should I multiply the top by?
-5.
You could do a negative 5 on top. If we do negative 5 on top, what do we have to do on bottom? Positive 3, right? Then we'd get a negative 15 and a positive 15, okay? You could have done a positive 5 on top and a negative 3 on bottom. That's fine too. Okay, so this would be a positive 3. And now distribute, okay? Do you see how it's really important that you show me your work on these? One silly little mistake and it throws everything off. So show me what you're doing and take your time, okay? Okay, so now this is going to be negative 15x plus 20y minus 50 equals a negative 50. Okay, so negative 15x plus 20y equals negative 50. On bottom, we're going to distribute the 3. 15x minus 21y equals,
51.
thank you, 51. Okay. Still with me? Okay. Now we can eliminate our x. So now we're going to go add these two together. This is 0. 20 plus a negative 21y is a negative 1y equals negative 50 plus 51 is 1. So we divide by negative 1, and y is negative 1. Okay, so now you have a y value. That's great. Great starting point. Y is negative 1. We're almost done. We're almost done. We're almost done. What do you do with that negative 1? How can you solve for your other variables? Plug it in where? To any of your recent 4, right? You can plug it into any of these 4 because these are the ones that only have 2 variables. Okay, I'll plug it in right here. So it's going to be, thank you, 3 times x minus 4 times negative 1 equals 10. Okay, so 3x plus 4 equals 10. Take away the 4. So we get 3x equals 6. Divide by 3 So x is 2. We have 2 of the 3 variables, guys. How do we find z? Now plug those 2 into one of the z's. I would go here. Okay, I would take that very first one because it's got small numbers. So x is 2 minus 2 times your y value is -1 plus z equals 7. So this is 2 plus 2 plus z equals 7. So take away this 4 from both sides and you get, oh, that's a z, not a 7. So you get z equals 3. The top one, the very top one. X minus 2y plus z. So your answer, 2, -1, 3. That's fun, right? It's a lot. I know it's a lot. You don't have a lot of them in the homework. I don't remember how many it is, but we definitely didn't do a ton of them. Hey, just be grateful you're Wednesday. My Thursday class has to do this, and there's 2 lessons, one of which is this one. You have 2 days. They have 1. Okay. So, how do we do? Got it? This one, okay, and you have options. You don't have to eliminate your x's first or your y's first or your z's first. Pick the one that makes the most sense to you, okay? I think on this one, I'm going to eliminate x first. Yep, I would do x first. Okay, so my first one, I would take the black equation and the red equation, because that's going to help us eliminate our x. Okay, so start there. Just be grateful for copy and paste. All my other classes in the past, that's not been an option because we didn't do all the notes on the iPad. Be grateful, right? So much to be grateful for. Okay, so if I add these, x plus a negative x, that's 0. 1y plus a negative 2y is a negative 1y. 2z plus z is a 3z equals 13. Okay, so we eliminated x from 1 and 3. So now we can't use 1 and 3 again to eliminate x. We need to eliminate x from 1 and 2 or from 2 and 3. Which one do you want to do? 2 and 3, because that's already a negative. That keeps it simple. Okay, so we'll do 2 and 3 now. Take a copy of 2 and 3. Okay, what do we have to do to be able to eliminate here? Multiply by 2. Yep. And I'm actually, well, I'm just going to do this. I'm going to take a copy of that purple one again so that I can stack them so you can see them right by each other. So that's my purple. My red one becomes negative 2x minus 4y. Did someone say wait? Yeah. Plus 2z. Did I lose you?
Wait, you take the purple equation and the red equation?
The purple and the red, yeah. But now I'm multiplying the red by 2. And don't forget to multiply that last piece. That would be 20. Okay, so that's purple with red multiplied by 2. You with me?
Wait, we multiply red by 2
to get opposites of x. Yep. We good? Yes. Okay. Moving on. We're going to add these together. This is 0. We have 1y plus a negative 4y. So that's a negative 3y plus 5z equals 27. Okay, so now look at what we have. This y and z and this y and z. Okay, so now we're going to do an elimination again with those. So you have, take a copy. You guys, you have no idea how nice it is to just copy and drop these in. You used to have to rewrite these all the time. It took forever. Okay, so we're looking at these two. That's just the blue and the new blue, the new red. How do we eliminate? I'll tell you what I would do. I would multiply the top one by -3. So if I multiply that top one by -3, so this guy by -3, I'm just going to put it in right here. That's going to be a positive 3y, a negative 9z, and then a negative 39. Big size. Okay, add these together, and then we're almost done. Negative 3y plus 3y is 0. 5 plus negative 9 is negative 4z. 27 plus a negative 39 is negative 12. And then we divide by -4. So what's z? Z is 3. Okay. Then once you know z is 3, go back to one of the ones that only has 2 variables. Okay, so I'm going to take this 3 and I'm going to drop it in right here. So it's a negative 1y plus 3 times 3 equals 13. Okay, I'm going to take away this 9 and I'm running out of room. I'm moving over here. Negative 1y equals 4. And then divide by -1. Okay, so y is -4. Z is 3. Now we got to find x. Johnny.
Can you plug the z into any of the equations?
Any of the two that only have two equations. So this one or this one, right? Because if you plug it into one of these, then you have 2 unknowns and you can't solve with 2 unknowns. Yeah. Can you wait till we're done with this? Okay. Go fast. So you have -4 and 3. I'm going to plug those two into this first equation. Okay, so it's x plus -4 plus 2 times 3 equals 3. So this is x. -4 plus 6 is a positive 2, so x plus 2 equals 3. Take away that 2, and x is 1. So your answer is 1, -4, 3. And I don't care if you just leave it as x equals, y equals, z equals. That's fine. You don't have to write it as coordinates like that. How'd we do? It's a little crazy, but it's really fun. Okay, this one's much better. This one's much better. We start with the harder one, okay? Substitution is actually a lot easier on these problems. Let me show you why. What do you see here? We have one almost solved, right? We can solve for z real quick. So let's do that. We're going to divide by 2 and divide by 2, and z is 2. Isn't that nice? Okay, now that we know what z is, what do I do next? Plug it into the purple one. Solve for y. So it's going to be y plus 3 times 2 equals 6. So y plus 6 equals 6. Take away the 6. And y is 0. Do you love this one so much better already? Now plug the y in here and the z in here. So 2x plus 0 plus 2 equals 8. Simplify and solve. 2x plus 2 equals 8. Take away the 2. So 2x equals 6. Divide by 2. So x is 3. So your answer is 3, 0, 2. So much better, right? Look how quick that is. That's a quick one. Okay, last thing, and then I'll give you the rest of the time to work unless you have questions on the quiz. We'll go over those too. What? It's a word problem. It is a word problem. But I'm going to break it down for you right now. It's going to be great. It's going to be great. Okay, word problems. Don't let them freak you out. They're not bad. You just got to break it down one piece at a time. So it says this. A clothing store has a budget of $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? Woo! So first you have to define your variables, okay? I'm going to do X, Y, and Z. If you're working on a word problem and you want to do A, B, and C, or you want to do R for rugby and T for t-shirt and what's our other one? P for polo, that's okay, okay? I'm going to use X, Y, and Z just for the sake of keeping it familiar. So I'm going to call t-shirts my X. I'm going to call my Y polo shirts. And I'm going to call my Z rugby shirts. Okay, so we have to set up a system here. We know there are 200 shirts. Can you write an equation for 200 shirts?
X plus Y plus Z equals 200.
Yes, X plus Y plus Z is 200. Okay, if we add up all the shirts, there should be 200 of them. Okay, now let's talk money. Can you write an equation that involves the money for these different shirts?
$6,000 total.
12 is t-shirts, so 12 times however many t-shirts plus 24y plus 36z equals what? 6,000. Equals 6,000. Okay, so we know those two are true. Now this last equation that we need, it says if you want to have twice as many rugby shirts as polo shirts. So rugby shirts is your Z, polo shirts is your Y. What would that equation be? Z equals 2 times Y. Do you know what that means, guys? You get to do substitution instead of elimination. Easy, easy, easy. Okay, so Z equals 2Y. What did it tell us? It didn't tell us. Oh, they didn't give us, yep. We don't have a total though. I mean, we have a total. We don't have a number. Okay, but still easier than elimination, promise. Okay, so we know that Z is 2Y. The first thing I would do right here, is I would simplify one of our equations because one of our equations is not awesome. Which one?
The middle.
The big numbers, right? All of that stuff, all of this is divisible by 12. So I would just right off the bat, divide by 12. Okay, so step 1, divide by 12. So your new equation would be X plus 2Y plus 3Z equals 500. Much nicer, right? And you're allowed to do that. It doesn't change any values. If you divide everything by the same number, you're good. Okay, so we're going to be using this equation. So we're ignoring this one now because we just divided, and this equation. So that's your system, those three. The first thing I would do is substitute. What can we substitute?
For the Z.
For the Z. Everywhere you see a Z, you can plug in a what? 2Y. So I'm going to put 2Y here, and I'm going to put 2Y there. Okay, so I'm going to rewrite this guy, my bluish greenish one. X plus Y plus 2Y equals 200. Okay, a simpler way to write that would be what? X plus 3Y equals 200. Okay. So I just substituted from here. Now I'm going to substitute with my true blue here. This would be x plus 2y plus 3 times my z value, which is 2y, equals 500. And again, we can simplify that. 2y plus 6y would be 8y. So this is going to be x plus 8y equals 500. You with me?
Sure.
What can we do from here? Just look at these two equations. What can you do? You can eliminate, right? Eliminate your x's. If you want to multiply by a -1 just to make them opposites, you would get a negative x minus 3y equals a negative 200. Otherwise, you could just subtract them, right? But I don't want to encourage that just for the sake of lacking confusion. So add these two together. X plus a negative x is 0. 8y plus a negative 3y is 5y. 500 plus negative 200 is 300. So solve for y, divide by 5. You get y equals 60. Okay, y is 60. Okay, zoom back out here. What can we do with y is 60?
You can do z.
Plug it in to which one?
Z equals 2y.
Plug it into z equals 2y would be your easiest option. So if we plug it in here, z is equal to 2 times 60. So z is 120. Now what? Plug it into which one? I would plug it into that very first one, right? So it's x plus y, which is 60, plus z, which is 120, should equal 200. So x plus 180 equals 200. Take away the 180. So x is 20. What does it mean?
There's 20 shirts, 20 t-shirts.
20 t-shirts. Yep, 20 t-shirts. 60, what was y? Polo shirts. And 120 rugby shirts. Whew! Good stuff, huh? Yes, I love it. Okay, you have 15 minutes. Get started.